Pi, a constant we use a lot in mathematics. The remarkable history of this constant, pi, extends over many years, almost from the beginning of recorded history to the present. Emma Haruka Iwa, a Japanese scientist, recently in 2022 computed and reached almost 100 trillion decimal digits. This number simply represents the ratio of a circle's circumference and diameter. Mathematicians all throughout the world have been devising new ways to find the value of pi. Since 2000 BC, the number pi has been examined, calculated, and thought about all throughout the world. This video gives you a brief computation history of this mathematical constant. Humans have known the value of pi for at least 4,000 years. In 2000 BCE, Babylonian mathematicians calculated the area of a circle using the circumference of an inscribed hexagon, yielding an approximate value for pi of 25/8 is equal to 3.125. In ancient Egypt, they calculated the value of as 256/81, which is approximately 3.16045. Sumerians also calculated the value of pi as 3 plus 23/216, which is roughly 3.1065. Around 1200 BC, the ancient Chinese used 3 as the value of pi. Using the Pythagorean theorem, Archimedes made a significant breakthrough in calculating a more precise value of pi around 250 BCE. He calculated the area of a circle by comparing the areas of a polygon inside the circle and one surrounding it. He was able to achieve an upper bound of 22/7 and a lower bound of 223/71 for the value of pi. He did this by demonstrating that there existed a constant ratio between the area of a circle and the square of its radius. Mathematicians all throughout the world were able to increase the number of known decimal places of pi by completing extensive calculations in the centuries that followed. In 263 AD, Lu Hui independently discovered the method used by Bryson and Antiphon, and calculated the perimeters of regular inscribed polygons with sides ranging from 12 to 192, arriving at the value pi equals 3.14159, which is absolutely correct for the first 5 digits. Zhu Chongzhi, a Chinese mathematician and astronomer, contributed to these computations by estimating pi to be around 355/113. Little development was accomplished until the end of the 16th century. François Veit, a French lawyer and amateur mathematician, used Archimedes' method to get 393,216 sides by starting with 2 hexagons and doubling the number of sides 16 times. His final answer was between 3.14159265535 and 3.14159265537. More crucially, Veit was the first person in history to use an infinite product to describe pi. Adrianus Romanus calculated pi to 17 digits after the decimal in 1593 using a circumscribed polygon with 230 sides, 15 of which were right. 3 years later, a German named Ludolf van Sullen demonstrated 20 digits using the Archimedean approach and polygons with almost 500 million sides. Van Sullen had correctly identified 35 digits. Germans still refer to pi as the Ludolfian number to honor the men who had so much perseverance. It should be emphasized that until this time, there was no symbol to represent the circumference to diameter ratio of a circle. William Jones used the symbol pi to denote the ratio in 1706. It was not widely acknowledged until 1737, when Leonhard Euler began using the symbol pi. It was then widely accepted. For the following few hundred years, progress stalled as more computations were performed but with little conceptual advancement. In 1873, William Shanks, an Englishman, used the procedure to compute 707 places of pi. Many years later, it was revealed that Shanks had deleted 2 words somewhere along the way, resulting in just the first 527 digits being correct. Ferdinand von Lindemann demonstrated the transcendence of pi in 1882. This means pi is not an algebraic equation solution. In the early 20th century, Indian mathematician Srinivasa Ramanujan devised an exceptionally fast method for computing pi based on its reciprocal fraction, which was eventually incorporated into computer algorithms. Finally, another breakthrough occurred in 1949, but it was not mathematical in nature, it was the speed with which the computations could be performed. The ENIAC, Electronic Numerical Integrator and Computer, was finally finished and operational, and a group of mathematicians fed in punch cards and let the massive computer calculate 2,037 numbers in only 70 hours. A decade later, the IBM 704 could compute 16,167 digits. The IBM 7090 crossed the 100,000-digit barrier in 1961, while the CDC 7600 reached the millionth decimal point of pi in 1973. Emma Haruka Iwa, a Japanese scientist, recently in 2022 computed and reached almost 100 trillion decimal digits. Mathematicians are still looking for probable patterns inside pi, if its digits ever start repeating.